Okay, so before we talk about how long the pipe must be, let's discuss whether the pipe should be open or closed. So if we look at the chapter, if we read the chapter properly, we know that for an open pipe, two successive harmonics differ by the fundamental frequency. So this is for the open pipe, and for closed pipe, it's twice the fundamental frequency. So before we begin doing any before we begin making decision, let's see what's the difference between the successive harmonics. So we have 280 and we have 320. So the difference between the successive harmonics is 40 hertz. Now, if it's an open pipe, then this will be the fundamental frequency, and if it's a closed pipe, then we'll have, since it's twice the fundamental frequency, so then it will be 20 hertz. So let's write that down. So for open pipe, your fundamental frequency will be 40 hertz. So let's put an if there, and let me write it a better way. If it's an open pipe, and if it's a closed pipe, the fundamental frequency will be half of it. So that's 20 hertz. Now, how do we know that this, if it's an open pipe or a closed pipe? Now, what you need to do for that is the following. So we'll talk about this equation later. Let's first discuss what we need to know. So let me mark that down because we need that. But anyway, so let's divide our frequency by the fundamental frequency. So we have 280 hertz, and if we divide that by 40, so let's write open here. If we write 40, then we get 7, and if we divide 320 by 40, then we get 8. So these are all integers. So it is a possibility that it's an open pipe. Now let's see if it satisfies the closed pipe condition or not. So for closed pipe, as if we look at the calculation, we'll have closed, and for that, if we divide, pardon me, 280 by 20, we get 14, and if we divide 320 by 20, we get 16. So as you can see, this is not successive, and they are even numbers. But for closed pipe, it has to be odd number. Has to be odd. So that means it cannot be a closed pipe. So that means if we have integers, then we can easily say that it's a possibility of being an open pipe. And if we see that these are even numbers, so we can definitely say that it's not a closed pipe. So the pipe is open. Now let's talk about how long the pipe must be. So to do so, first we need to know this equation where frequency is equal to the velocity or the speed of sound divided by 2L, where L is the length of pipe, and we are using 2L because it's an open pipe. So, and to get the velocity, now we know the velocity of sound wave, or the speed of sound wave at 0 degrees Celsius is 331 meters per second at 0 degrees Celsius. But we don't know the velocity at 23, right? Because that's what is given. So we need to figure out the velocity at 23, and that's when this equation comes in handy. So if you look at section 12.1, it gives you the velocity at a certain temperature, and so this will be in meters per second because this is in meters per second, and this is the temperature in Celsius. So for our case, temperature is 23. So what we'll get here is 331 plus 0.6 times 23 meters per second. Now we know the velocity, so this will be velocity at 23 degrees Celsius. And since we don't know the L, so L will be this over 2F. Now, since it's an open pipe, our fundamental frequency is 40 Hertz because it's open. And if we plug in all the numbers, we'll get the following: plus 0.6 times 23, and that meters per second divided by 2 times 40 Hertz. And if we solve for it, we'll get a value of 4.3 meters. Thank you.